We are UW Crows from the University of Warsaw. Our team was founded this year and we all come from the Robotics and Automation Club established at the Faculty of Physics last year. Though we are a small team, we are driven by a shared passion for electronics, engineering and software. Parts of our rover, Rover, was inspired by Anteros, a previous rover developed by an earlier team at the University of Warsaw, which closed around 2020. Our team is led by Mateusz Kamiński, who coordinates the work across all sections. We're organized into electronics, software, mechanical, drone and science teams. Each section has its own leader to guide the work and support the members. Since we are a small group, our work is highly collaborative. Many of us are active in 2 or more teams. We started this journey because we wanted to pursue hands-on engineering and robotics projects. Unfortunately, such opportunities are limited at the University of Warsaw, which is why we created our club. We then searched for a challenge that matched our skills and resources. Building a rover felt like just the right fit, ambitious but within our reach. Moving on to the rover, its main frame is constructed from aluminum V-slot profiles. A modular, 3D printed cover encases the electronics, shielding them from dust and moisture. Side-mounted fans with protective filters ensure internal airflow and prevent overheating. Large rubber wheels provide grip and stability on uneven terrain while helping absorb shock and vibration. The rover is also equipped with a force shutdown button on the side, which immediately cuts all power. Our mechanical section is primarily handled by 6 team members. Their responsibilities include designing detailed 3D models of each component ready for 3D printing. Less critical parts, such as the rover's outer shell or decorative elements, are printed using PLA. Components subjected to some mechanical stress are printed with PET, which offers better durability and structural integrity. The key mechanical elements are prototyped through 3D printing and later made by ourselves from aluminum or steel, with the help of the Faculty of Physics Mechanical Workshop. We are currently developing a suspension system to further enhance stability. Our planned design uses a bicycle-style mechanism with 2 connection points between each wheel and the frame. We will begin testing once all parts are assembled. If the suspension fails, we can fall back on rigidly mounted wheels, less flexible but proven solution. The rover's robotic arm is powered by a total of 6 motors. The rotational axes are measured using incremental encoders, either mounted directly on the motor or on the axis itself. The base rotation of the arm is driven by a rotational motor, allowing for 360-degree movement, limited only by the cable routing. 2 linear actuators control the forward-backward and upward-downward movement of the end effector. Another 2 rotational motors provide pitch and roll control for the gripper. The roll axis is not limited by cabling, enabling continuous rotation. The final motor operates the gripper's clutch mechanism. All motors are DC and are driven by custom motor drivers, which support 3 control modes: power, position and speed. They are based on STM32 microcontrollers programmed in C with CAN communication and high-power Polo driver. The rover's software is built on ROS2 and manages both the arm and locomotion systems, as well as the telemetry through our custom-developed nodes. We utilize the Joy package for gamepad input and the socket CAN package for communication over the CAN bus. Future development will integrate ROS2 control and move it for enhanced motion planning and control. The rover is powered by 6S LiPo batteries, which are connected to a custom-designed PCB that distributes power to all subsystems. Our onboard computer is the NVIDIA Jetson Orin module, connected to a Ubiquiti rocket antenna for remote control, and to USB hubs that manage the input from 6 onboard cameras. Soon we will add an additional 3D camera. Camera interface is made separately from ROS2 and written in Python using network sockets. Our software also enables changing the resolution of each camera while controlling the rover. This design allows for easy integration of neural networks and Aruka code detection, which will be essential when adding autonomy. The power board uses magnetic relay switches to control the on-off state of the 5V, 12V and 224V power sections. The 5V and 12V outputs are provided via step-down converters. An additional onboard microcontroller is implemented for communication with the main computer. Not all features are fully implemented yet, as a shipment containing upgraded relay switches, current sensors and CAN transceivers was delayed in customs. The drill mechanism is operated by DC motors and actuators. The drill is mounted inside a guiding tube that aids in precise sample collection. First, the tube is pressed into the grout up to 30 cm by a linear actuator. Then, the moving drill is lowered inside the tube by another linear actuator. The drill descends up to 35 cm, ensuring the proper depth for collecting the sample. At that point, the DC motor stops and the linear actuator raises the drill. The collected sample exists through a vent placed on the tube. The geology science part is done by Norbert Niestor, who masters in Mars geology, and Alexandra Frączak, who studies geoinformatics and geology. As for the science part on board the rover, we'll create a custom PCB lab board with a microcontroller that measures the weight of the samples with tensometric beams and amplifiers, as well as measurement of pH through a pH meter. The drone is simultaneously connected to a ground station while being piloted using the Radiomaster Boxer. The drone is intended for extensive feature upgrades. So far, we have developed new drone legs, and upcoming improvements include redesigning the drone frame. The drone controller, in addition to basic flight control and arming-disarming function, includes a dedicated button for automatic landing to enhance safety. Thank you for watching and see you at the European Rover Challenge 2025.